Okay, so for series that has seasonal component, okay, instead of the previous Arima model, okay, we need to consider to remove the seasonal component first before we apply box Jenkins models to our series. Okay, that's why in this particular events, if you have a time series with seasonal component, we use ZT to represent the seasonal difference. Okay, the seasonal difference, it depends on our series, whether our series is a monthly data series or quarterly data series, and this ZT represent as YT minus YT minus 12 for monthly, YT minus YT minus 4 for quarterly. Alright, so after we perform the seasonal differencing to remove the seasonal component, suppose that our series is still not stationary. Okay, the next step is we further the differencing method with non-seasonal differencing. Okay, the non-seasonal differencing, WT. Okay, so this WT is actually in terms of Arima with seasonal component. This WT is actually ZT minus ZT minus 1. Alright, and remember ZT here, it depends on whether our series is monthly or quarterly. Okay, this Arima formulation have it known have it names. Okay, we name it as Sarima, where S is denoted as the seasonal component, and the general equation to represent Sarima is, okay, here P dq, the small letter P dq and the capital letter of P dq. Okay, so this is for AR. Okay, this is for MA. Okay, D is for how many non-season different that we need. Okay, and the capital letter P here is for SAR. The capital letter Q is for SMA, and capital D here is how many seasonal differencing. Okay, so 12 here means that we will have a monthly data series. 4 here, it means that we perform the Sarima model toward quarter data. Okay, and here for example, we formulate Sarima 112.111 for quarterly data. Okay, I hope that you take a look at this equation. Okay, and at the end of it, we will use backshift operator to represent this particular model. Okay, and at the end of it, as we can see here, okay, we will get this particular backshift operator. Even from this backshift operator, we can determine the PDQ, the small capital PDQ, and the capital letter of PDQ. Okay, this PDQ. So here, as we can see here, 1 minus phi1b, this is for AR 1. So AR1 here is 1 minus phi1b. 1 minus b is how many non-seasonal difference that we need. Okay, how many non-seasonal difference that you need? It is actually 1. Okay, and then, alright, and then 1 minus beta 4. This is how many non-seasonal difference that you need. Okay, so it is okay, 1 minus 1 minus 1 and so on. Okay, so at the end of it, okay, at the end of when you combine the seasonal and the non-seasonal part of Sarima, okay, the last equation here will represent okay, they represent the seasonal Arima for 112.111. So here, let's take a look at the left side first. Okay, 1 minus phi1 beta here represent the AR1 part. 1 minus B here is the first order of non-seasonal. Because of what? B here is without the 1 minus B here is without the power of any non-orders. The difference between the non-seasonal and seasonal differencing is, for seasonal differencing, it will depends on, we do the differencing on what type of data, quarterly or monthly. If monthly, B12. So this is actually the seasonal, the different of seasonal part. So this is the capital letter of D. If the coefficient, if with this particular B4, it means that it is for the seasonal part. This is for the left side. For the right side, this is for for MA part, and this is for SMA part, and so on. We can replace B4 with B12 for monthly, and if we want to write it in terms of YT, we will have this particular equation. So for summary on how to model a box Jenkins model, suppose that for step 1, we check first whether our data series is stationary or not. If a stationary, we develop ARMA model based on the ACF and PACF pattern. And next, suppose that the data series is not stationary. We have to consider whether we perform the non-seasonal differencing or seasonal differencing. So you have to check the seasonal component first. If there is actually seasonality in your series, we have to perform seasonal differencing first. But if there is no seasonal, we will perform the non-seasonal difference. So if we have non-seasonal data, we will construct an ARIMA model. This PDQ order will depends on the ACF and PACF pattern. I will discuss in application part. Suppose that if seasonality effect is present, so we have to perform the seasonal differencing first. If after we perform the seasonal differencing, and we already eliminate the seasonal effect, but still the series is still not stationary, so we perform a non-seasonal difference. So in case of seasonal effect is present, we say that the most suitable box Jenkins model that will perform is actually the Sarima model. And now we have to determine the PDQ for AR and MA, and PDQ for SMA and SAR. Again, this is actually based on the ACF and PACF plotting pattern that I will explain later on evaluation part. Right? So I think that's all for the theoretical part on basic model of box Jenkins. If you have any question, you can ask. So thank you guys. Bye.